it will be nice to know from which field you are coming from and why you're interested in machine learning, and maybe a little bit about your background or where you are connecting from, just to see how this crowd is organized. Thomas says, I want to follow artificial intelligence in my college. Mo would like to extend his JavaScript programming skills. It's really good that we have all these great machine learning libraries for JavaScript these days. We have TensorFlow that we will cover today, but there are also other libraries. And machine learning is now so close to web developers and especially JavaScript developers. So nice to hear about that, Mo. Any other person would like to introduce themselves and say a little bit about their background and maybe your experience so far, maybe what you've seen, or Slim says, I'd like to have a taste of artificial intelligence. Didn't have the time to discover it yet, so this is a great opportunity. Yes, I hope that I will motivate you and get you to learn more and study and dive deeper into AI and machine learning. So I will try to make this as the title of the presentation. You will shortly see it's like a gentle introduction to machine learning and image classification through machine learning. Hello from Denmark. We see Mohammed. I'm a full stack developer student and interested to have a general idea since this is the future. Yes, I couldn't agree more. I believe machine learning is, well, it's kind of the present, let's say. It's evolving really fast, and we will see more of it in the near future. We have Thanos, student of the coding bootcamp, also interested in machine learning and AI, and thinking about transitioning in the future. That's great. Evelina is currently a graphic designer and aspiring developer. Machine learning is a very important part of all current interactive experiences. Yes, indeed. And there are different levels, let's say, of working with machine learning. So nowadays, you can approach machine learning and use machine learning through automated tools, through graphical user interfaces. So there are many levels, let's say, of where one can approach machine learning and use. You can either dive really deep and learn the mathematics and learn a programming language like Python or JavaScript and work with a framework. But also you can use some ready-made libraries that kind of abstract away the complexity and make it a little bit easier to dive and introduce yourself with machine learning. And there are also some tools or services these days from all the big players in AI like IBM, Google, Facebook, Microsoft, Amazon, where you get a graphical user interface and you can work with machine learning, and you don't have to even touch a single line of code. You can choose from several machine learning tasks, and even if you're not a programmer, you can leverage the power of AI and machine learning through some really interesting and quite easy, relatively easy to use services. So I think I will start sharing my screen. So let me share my screen and let me open the, let's wait. Okay, I think you can see my screen right now. Okay, so let's start. First of all, I will send you a link to the notes for this webinar. So let me make this public. So this is a link where I will be keeping some references and notes from today's webinar. And I will also send you the link to the slides. You can find the links to the slides here. So I can also share the slides with you. So let's start. This is titled A Gentle Introduction to Transfer Learning. We will see in the process what transfer learning is. The main title is, of course, Custom Image Classifiers with TensorFlow.js. TensorFlow.js is a machine learning framework by Google that runs on JavaScript. And we will be using TensorFlow.js today to classify images, to let these algorithms that are used by TensorFlow.js to classify some images that we will be choosing. And we will try to work our way towards like a shopping experience, to enhance the shopping experience. So we will be able to classify images of products so that customers can scan the products with their mobile phones, and the classification algorithm will be able to detect and the product that is currently being scanned or photographed, and an automatic addition to the shopping cart will be will come next. So the inspiration from this talk and this presentation came from a couple of articles about this new trend of contactless shopping or staff-free shops, especially due to the COVID situation. So this all started with this link. I will play the video for it's just a couple of seconds. So this was the source of inspiration for this webinar. I was watching this video, and there was this shop where you could scan the products with your mobile phone, and they would automatically be added to your shopping cart. So this was the video that inspired this webinar. I will place it right here. I'll place the link right here. So when I saw this video, I immediately tried to see if I could make something with JavaScript that was similar to this experience. So I wondered how long it would take for me to come up with an algorithm that will detect a product or products through a camera, and then it will automatically detect and add this on the shopping cart. So I launched my code editor and I used TensorFlow.js to create the experience that you will see next. So this is a proof of concept. This is a shopping cart or an e-shop called Senior Tensor because of TensorFlow. And I'm going to open this. There are 3 products currently that have been classified by the algorithm. There's TensorFlow.js running. So I'm going to start the camera here, and then it's going to take a few seconds to be able to scan. And now I will hold these products in front of the camera, and you can see it can detect the product, and it automatically adds this product to the shopping cart. If I put it, I don't know, somewhere here, you can see it needs a little bit of a good view of the product. Let's see if it needs to be somewhere here. And then I can have other products that were classified. And it was able to, of course, we can scan it again. And it was just a proof of concept that used the TensorFlow.js and an image classification algorithm to run this shop. I used a template from CodeDrops to build this interface, but the underlying algorithm and the machine learning system was made with TensorFlow.js. And if you take away this, like the HTML and the CSS that I spent quite some time to make, the actual process of creating a very basic example of classifying these 3 products, as you can see, took less than 15 minutes. And I want to show you the process of doing this. And we will see different approaches from the easiest one to a little bit more advanced. Let me send you the link to the notes. So the GitHub repository for this presentation and the code that I'm going to share will be available on this GitHub repository. So I'm going to place this also on the notes. As we move on, I will be. So the technologies that we are going to see today are JavaScript, of course, which is the programming language that we'll be using, TensorFlow.js, which is the machine learning library, and MobileNet, which is the machine learning model. This is the image classification algorithm, this image classification model, and to be more exact, that will be used along with TensorFlow.js to recognize images and also learn how to detect images of products that we will train ourselves. So the objectives of this presentation is to learn, give you a quick introduction to machine learning, then a quick introduction to image classification with machine learning, the product classification that we will see, and a little bit of an introduction to transfer learning with machine learning. We'll talk about this in detail. So let's talk a little bit about what is machine learning. And I want to start with a short story. So once upon a time, there was a little girl with a laptop on fire in the middle of the street. The girl's name was Chloe Price, and she was the daughter of Nathan Prescott, the CEO of Prescott Industries. She was also the only child in her family to attend Prescott's private school, Blackwell Academy. Chloe's mother, Rachel Amber, had died in a car accident when Chloe was just a few months old, leaving Chloe and her older sister Max to raise themselves on their own. It was at Blackwell that Chloe met her future best friend, Warren Vidic, who would become her mentor and mentor protege for the rest of her life. The two would go on to form a friendship that would last a lifetime, as well as form the foundation of Max's life as a hero. What I've just read was just a fictitious story created by machine learning trained on millions of texts from the internet. The only part that was actually written by me, by human, was the first sentence. So this is a machine learning algorithm that was fed with a single sentence, the first sentence, once upon a time, and then the algorithm, based on its knowledge, on its vast knowledge of human text, created this story from scratch. And as you can see, it's like human-like writing. So how did we get here? How did we get to the point where machines could like write these really lifelike and human-like texts and stories? So the old way of using computers, let's go back before AI and before machine learning. So the old way of using computers was, and still is, let's say the more standard way, is to provide some data as input to the computer, like two numbers, for example, 4 and 6. Then we provide a set of instructions, very specific instructions. This is the program. For example, we provide a plus operator, an addition operator. And then the computer follows the instructions, processes the data accordingly, and produces the required result. For example, 4 plus 6 equals 10. So we get the result of 10. Now, the new way of using computers is slightly different. We provide lots and lots of data as input to the computer. For example, handwritten characters. I will give you an example. We have these handwritten characters, which are, of course, the numbers from 0 to 1. So some people just wrote these characters on paper, and this data serves as the input to the computer. We accompany each piece of data with some kind of label, meaning we say to the computer that the character that you see now depicts letter A. This picture of a character that you see depicts letter B. So every single character, handwritten character, or an image of a handwritten character is accompanied by a label, some description about what this image shows. We use various algorithms to train the machine on these labeled examples. And then the machine learns to recognize each character from this set of data and the labels. After we have trained this model, we provide new, unseen before data to this trained machine learning model. And this model will be able to predict the label, meaning which character it sees, out of some new data. So given the characters that we have just seen, along with some labels, like this is 0, this is 1, this is A, this is B, this is C, and of course we're talking about thousands of handwritten characters, we were able to train a machine to be able to predict the letters that are handwritten, and the handwritten characters that it have never seen before. So that's machine learning in a nutshell. It's like you can think of it as a kit. We show some images of, let's say, cats, and we show some images or photographs of dogs. And for each image, we say to the kid, look, this is an image of a cat. This is an image of a dog. After a while, after providing this, let's say, after this learning session, we show this kid a new picture, a photograph that it hasn't seen before. It can either be a cat or a dog, and then the kid will be able to say with some certainty, like, okay, what I see before me is a dog or a cat. So you can think of machine learning like this concept. It's not about giving very specific instructions, as was the old way of programming, but instead we teach the machine, and the machine learns using lots and lots of examples. In order to test these algorithms, I have a demo set up, which I want you to test yourselves. So this machine learning model was trained on this character recognition set, and when you write something here, it will try to detect the letter. So you can draw anything you like. This is with JavaScript. And from these handwritten characters that, of course, it hasn't seen before, it is able to guess, as you can see here above, the numbers that are drawn on the board. So this is like a basic machine learning algorithm. So as you can see, you can create some really crazy handwritten characters, and it will be able to recognize the characters. So play around a little bit to see if this application was set to be created using programming, like the standard way, giving very, very specific instructions to the computer and guide it to specific steps given an image that or a drawing that it sees, it will be close to impossible to do this because we have data that's unpredictable. We cannot like predict that I will write all these characters and all these pixels this way. I can use, as you can see, different styles and different shapes. So it's almost close to impossible to program, to give specific instructions to a computer. So the way that we do it these days is that we provide lots and lots of examples of characters along with the accompanying labels. And based on several algorithms, the machine learns to detect and see and understand and predict the characters. By predict, I mean that we the machine is always giving us a probability, of what it sees. It's never, a machine learning model will never say that I'm 100% sure that this is a character B or C, or this is a dog or a cat. In machine learning, we get probabilities ranging from, let's say, very small percentages up to 99.9%, not most of the times. So, for example, if I do something like this, you will see it's just predicting what I have written was not close to A, and given a very small probability, it was able to give some prediction A. Now, on most of the algorithms, we can see the probabilities. So given a threshold, given a limit, like if we say, okay, if you are sure or certain above a certain threshold, a certain level, if you're like 80% sure that this is an A, then go ahead and draw A. Otherwise, if the probabilities are low, like 80, 70 or less, then just ignore the character. So we are able to see the probabilities out of this prediction algorithm and be able to accordingly act. So Curie says, how does it handle small case I and the letter 1 and small case L? Yes, that's one thing. So how can we write, I guess, J? You can see that in some characters, we're going to have some ambiguation. For example, L, or let's say I, it's going to have quite a hard time to understand I. So yes, you're right. These algorithms are trained, they are tested, and then they are trained again with new data, or the parameters are tweaked, and we get to make these algorithms perform better. So it can understand the difference between B and 8. Let's see if Yes, it can understand B and 8, but with I, as you can see, okay, this is 1, but this, okay. So we have kind of like a problem with I. But for the rest of the characters, as you can see, it works pretty well. So that's just an example of a machine learning algorithm running on the browser using JavaScript. At this point, I want to talk a little bit about the term model that I mentioned. So a machine learning model is a concept that you will see very often, and you will, of course, will see it in this lecture. I want you to think when you hear the word model, you can think of this story, of this concept. So imagine that we have a newborn baby, and that baby has like absolutely zero knowledge of the world, of anything. It knows nothing at all. And we take this baby and we teach it to understand just one very specific single thing, like to understand the difference between mom and dad. So the only thing that we kind of teach this newborn baby is to see the father figure and say dad, and see the mother and say mom. That's the only thing that we try to teach this newborn baby. Once we have trained the baby, and the baby is able to say mom or dad and just distinguish between these two persons, if at that moment you can think of this baby's brain, which knows absolutely nothing apart from distinguishing between its mom and its dad, that can be closely related to the machine learning model. So a model is like a digital brain that knows about a very, very specific task. It knows about the distinction between, let's say, several characters. So when you hear the term model, think of as a digital brain that was trained on data, and that model is able to predict some kind of images or characters, or do some very specific task. So that's the concept of a machine learning model that we see all the time in, of course, an analogy. So what are the advantages of using machine learning? So there are lots and lots of advantages, but I will just name a few. So there's no need to rewrite the program for new data. So if we were to program some kind of algorithm or some kind of program to detect or work with some data, it turns out if we get some new data that we didn't expect, we have to rewrite the program, because we want the program to be able to handle new data. So we're given, I don't know, a program that handles, let's say, integers and produces some kind of output. If the client asks us for the program to be able to handle floating point numbers, we have to go inside the program and rewrite the code and the logic in order for the program to be able to handle some new kind of data. So with machine learning, we don't need to rewrite the algorithm or the program for new data. We train it with 1,000 pictures, let's say, of 10,000 pictures of A, 10,000 pictures of B, 10,000 pictures of C, and then there's new data coming all the time, new characters A, B, C, written in all kinds of ways, and the machine learning model is able to recognize, to predict, let's say, these characters, this new unseen data. So there's no need to refactor the program or to make it adapt to some new data. It can work with tasks that cannot be programmed. For example, image classification is a really, really hard task to be programmed. We have all this complexity in the images, different variations, different colors, different shadings, different brightness. So it's almost close to impossible to be able to program an application that will be able to distinguish between a cat and a dog or something similar. But machine learning works really, really well with this kind of tasks. The task of translating one language into another, the task, let's say, of suggesting a similar movie or a similar song according to our tastes. So these are tasks that are handled really well by machine learning. So how can we program an image classification algorithm? Okay, this is a rhetorical question. It's pretty hard, even close to impossible. Another advantage is that the machine learning algorithms are outperforming humans in lots and lots of tasks, mainly classification tasks and predictions. Especially in the last few years, we've seen machine learning algorithms outperforming humans in many, many tasks. We've all heard about, okay, the world champion of Go was, there was an algorithm, a machine learning algorithm that won the world champion of Go. We already know about Garry Kasparov and how IBM's Deep Blue AI system was beat Garry Kasparov. It also, IBM's Watson AI system beat the world champion or the champion in Jeopardy in the knowledge quiz. And there's all sorts of papers coming out almost every month about some algorithm that outperforms humans in detecting, let's say, some medical conditions or other tasks. You can read more on the slides, at the bottom of the slides. So how are these algorithms trained? What's the underlying, let's say, algorithms? So in this example, I'm going to try to show you one of the, let's say, simple algorithms that we use to train a machine learning model and be able to distinguish between two different fruits, as you can see. So there's a lot of math involved in machine learning, and I will try to make this as simple and as visual as possible. So this will be a high-level overview of one of the algorithms that we use in machine learning. There are several algorithms that we use. Linear regression is probably one of the, it involves a little bit of math, but I think you will. So I will start with some basic math here to see how this linear regression algorithm works. So we have this coordinate system. We have the x-axis here, which has some values, and we have the y-axis here, which has some values for y, let's say. Now, if we're going to take to create a graphic equation, to draw a line, let's say, and say, okay, for each x, for each value of x here, right? If the x was 1, 2, 3, or 4, we wanted the y to be something constant. Let's say we wanted a to be 4, for example. I would write an equation like this. So for every x, no matter what the value of x, like 0, negative 7, 7, 4, the y would always be 5. So if we were to draw a line across all these points, so for x4, the y would be 5. For x equals 7, it will also be 5. For x equals 12, it would also be 5. So if we were to draw a line for this y values, we will see a straight line passing through 5 for all x values. So this is just a simple line crossing the. Now let me see if I can delete these ones. Now let's manipulate this equation and give it, and let's say multiply it by, let's give it an x value. So if we provide, instead of providing the value of 5 to the y, and we give it the value of x, if we draw the points now, so if x is 2, then y will be equal to 2. So we'll get a point here. If x is equal to 6, y will be equal to 6. If x is equal to 10, it will be equal, y will be equal to 10. And so if we draw a line across these points of this equation, we get this line. So let's move a little bit forward and add another variable here and multiply x by 2. So we have this diagonal line crossing from 0.0 and going all the way upwards. So if I add, let's say now a number, let's make it 3. So if I add a number here and I multiply x, you will see that suddenly the line moves a little bit to the left. Why? Because now for every x, so for example, if x is 2, then y will be 3 times 2. So for x equals 2, we're going to have 2 times 3, 6. For x equals 3, we're going to have 9. And there will be a point here. So if we draw a line across these points for this equation, we'll get this angle, let's say. We kind of like turn the line that we saw before a little bit to the left. We can rotate it. So this number here, as you will see, is able to rotate the equation, the angle of the equation. So we have by 1, the same as x. We have 4. So as we change this number, the line gets rotated. Now, if I'm going to add another number here, if I'm going to add, let's say 1, the line is going to stay in the angle that it was before, but it's going to move a little bit to the left. Why is that? Because for every x, so for x equals 2, we're going to multiply by 4. So this will be 8. And it will be, if we add also 1, it will move the line a little bit to the left. So this number here is able to move the line to the left or to the right by, let's say, by making the output of x, of y, sorry, based on x, a different value. So if we add 0, we just get the line crossing from coordinate system 0, 0. But if we add 2, if we add 4, and so forth. So if we play around with these values, and even if we use negative values, you will see that this number now actually moves the line to the left or to the right of the center. So if we were to, let's say, manipulate these two values, this multiplier here and this constant here, we would be able to rotate this line and also move it to the left or to the right. So I will do just that, and I will create a variable called 4 and a variable called b, and I will make it 1. And then I will substitute the 4 here with a and the 4 here with b. So we have exactly the same equation, but now the first number is a, and then the second number is calculated using the variable b. So if I move these values like this, so if I move b, you can see the number changing here. You see that the line is moving to the left and to the right from the center of the axis. And if I tweak this number, I'm going to get this rotation. I'm going to give some larger values here. So I'm going to say 15 and 15 just to play around more. And I'm going to change also the values here. And you will soon see how these algorithms work to classify. So up to this point, there's nothing like really new apart from some linear equations, some basic math. So we have an equation, we're playing around with this equation, and we are able to like rotate this line and move it according to two variables. So just by playing around with these two numbers, we're able to rotate this line. So let's now get to the actual classification algorithm using this linear regression method. Let's say that we want to classify between two fruits, between oranges and grapefruits. So I will try to draw an orange here. I still haven't found an orange. So I will make this an orange. Sorry for the drawing here, but just, and a grapefruit. You will understand why. So let's make this a yellowish shade. So we have these two fruits, and let me find the text. Where is the text? Here. So oranges, and we have grapefruits. So we have these two fruits, and we want the machine, the computer, which actually understands nothing but numbers, to be able to distinguish between these two fruits. So we give a bunch of oranges, we give a bunch of grapefruits to the machine, and we want the machine to be able to distinguish between grapefruits and oranges. So how can a machine distinguish between two fruits where it can only understand numbers? So for this, I'm going to simplify the example and say that we have just two properties in hand for these two fruits. We have the weight of each fruit, and we'll put the value of the weight of these fruits in this x-axis. So let's say these are grams. So I'm going to say this is x. This is the weight of the fruit, right? And the y-axis will represent the hue, the color of the fruits. So I will try to give you what I mean. So we have some values here that are close, let's say, to orange. And as we go up, the values will be close to yellow. So this will be a level of hue, color hue values going from oranges, let's say, to something more yellowish. Sorry, no, this one. So we're having like, think of it as a something, let me see, orange to yellow. Let's see, a gradient or hue. We're trying to think of this axis like if I was to rotate this, this is. So think of this as value starting from 0, going to 1, 2, 3, 4, up to, let's say, 10, 11. So this is just the hue axis. Lower values are closest to orange, and the ones here are closest to yellow. So we have just these two properties, and we place the x here, and we place the y here. Sorry, no, let's place y equals hue, orange to yellow. So now, just by thinking of fruits or oranges and grapefruits in these two properties, just thinking of their weight and their hue, we're going to point them, to place them here as points in this two-dimensional coordinate system. So I'm going to first add the oranges. Now, since the oranges are like not as heavy as the grapefruits, so they fall between, let's say, 2 and 8 grams, or let's say 20 and 80 grams, for example. And since they are close to the orange level here, to orange hue values, they will be placed right here. So oranges from 3 to 4 to 5 to 6 grams and close to this orange hue. On the contrary, grapefruits are actually heavier, so they fall between this side of the x-axis. They're like 10 or 11 or 12 grams. And since they have a yellow hue, they fall around this part of the y-axis. So we have the grapefruits. If we were to draw them as points on this two-dimensional coordinate system, we're going to be seeing two clusters. These points represent grapefruits, and they are two-dimensional points based on their weight and on their hue. And this is a cluster of oranges. So the machine now is able, let's say, to understand fruits only by these two numerical values. Numbers represent the X, the weight, and numbers representing the hue. Of course, the computer does not know anything about hue or weight. It just understands numbers. So here's how the machine learning algorithm works. The job of the machine learning algorithm is to be trained using these two sets and find the linear equation that will be able to distinguish between these two clusters. So we give these oranges and we say to the computer, these are oranges. We give these grapefruit values and we say these are grape values. And you, the computer, I want you to find the line that classifies these two clusters. So the algorithm works and says, okay, I'm going to create this equation and I'm going to assign some random values to A and B, like let's say this. So on the first time, we start with some random values. And then it tries to see if this line separates these two clusters. So to give you an idea, the optimal would be to have something like this. Not like, okay, let's say something like this. So we have a, okay, help me, okay. So, okay, just okay. So to have a line that will be able to separate points on this side and points on this side. So everything that falls on this side of the equation will be classified as a grapefruit, and everything that will be on this part of the equation will be classified as orange. This is the point where we want to get, and this is the job of the machine. So the machine starts by creating this equation with some random values. Let's say like this. And then it tests, okay, does this line really separate grapefruits and oranges? So it tests, okay, grapefruits are on this line, on this part of the line of the equation. Everything is correct here. Now, oranges, which should be on the other part of the line, are on the wrong side. So it's definitely doing something wrong here. So the A and B numbers are completely wrong. So right now, the machine learning algorithm uses an optimization algorithm, uses some kind of mathematical operations to see what is the level of this error. So how far from the best, let's say, from the optimal equation it is. And it tweaks these two values closest to something that will reduce the error. So if the error, let's say here is 90%, for example, it tweaks the numbers to get a smaller number, a smaller error number. So it tweaks let's say the number somewhere, what was that? Okay, somewhere here, let's say. And it tests again. Okay, what's going on with this classification? I see that some grapefruits fall on this side, but some others not. So there's something wrong in here. And also some oranges are on this side and others are here. So it tweaks again, it checks the errors, the error level, and it tweaks the numbers towards the direction that will minimize the error. So after a couple of training sets, it finds the numbers, let's go here, which are closest to the optimal, let's say, solution. These are the numbers that produce the least error. So at this point, we have all the grapefruits from this side, but we have an orange here. So it tweaks even more the numbers here to be able to arrive at the point where there will be the classification algorithm will work at its best. So all the grapefruits are on this side, all the oranges are on this side, and now we have a trained model. The machine itself, using some optimization algorithms, arrives at the point and says, I got it. I have an equation that will distinguish, that will make me classify between grapefruits and oranges. Hit me with new fruits. So at this point, after lots and lots of training cycles, we have this equation that was trained on the machine, and the machine itself found the optimal values for A and B. And it says, okay, give me some new numbers. So we say, okay, we got a bunch of fruits coming from a producer, but we don't know if they are grapefruits or oranges. I will give you the fruits, you will weight the fruits, you will see the hue, and we're going to have some new fruits like this. We don't know if this is a grapefruit, we don't know if these are oranges, we want the machine to distinguish between these two. So right now, using the trained model, which is actually a linear equation, the machine is able to predict whether these new values that it hasn't seen before are have a probability of being grapefruits, like this one, or the probability of being an orange. So for this one, there will be high probability of being grapefruits. And for this one, since they are closest to the line, they will have a little less probability of being oranges. So this is called the linear regression method, and it's used to distinguish between, for example, two different sets of things. And whatever we want to for the machine to be able to understand, to distinguish, to classify, we must provide some numbers. Machines only understand numbers, so everything that we need the machine to understand, we have to translate it in one way or another to numbers. We translated fruits into weights and hue. The images are also numbers. We have different colors and different brightness for each single pixel that comprise the images. So when we try to classify images, we give these small dots, these pixels, to the machines. So the images are translated into numbers, and everything that we feed to the machine is translated into numbers. Even human natural language is translated into numbers. Computers, and especially machine learning models, can only understand numbers. Now, in this model, we used just two properties to distinguish between these fruits. But if we can add some more properties, some more features, as they are called, to this training process, the machine will be able to predict with even higher accuracy. So for example, if we add another variable called Z, and that variable could be like the texture, let's say Z equal texture, going, let's say, from rough oranges to smooth for grapefruits, sort of. If we add another variable to the equation, we're going to get better predictions. But since this is a two-dimensional graph, if we want to put another dimension here, so another feature, we're going to have to use a three-dimensional coordinate system, a three-dimensional space. Of course, this is just a two-dimensional space, but you can imagine another axis coming here, going like to the back of the screen, and in that axis we're going to have values of Z, which will be like the roughness, let's say, of not rat. Okay, how can I edit? Why is it? It's rough, not rat. And as we progress, we can add even more dimensions, even more features to these models, to these training algorithms, and we are able to get more accurate results. So most of the times, these models work not with 2 or 3 features, but hundreds and even thousands of features. And of course, these high dimensional spaces cannot be visualized. So we cannot visualizing anything above 3 dimensions. So then after the 4th dimension or 4 features, we just let the math do its work. We are not able to visualize 4 or 5 or 10,000 dimensions, but these algorithms work really, really well with high dimensional data, as we say. So after we move on to like 3 dimensions, so let's switch from 2 dimensions to 3 dimensions, we're going to have something like this. So this is a 2-dimensional space with oranges, let's say, and grapefruits. Now, if we add another dimension, we're going to have X, sorry, this is X, this is Y, and this is Z. And then in order to classify these two clusters, we're going to use what is called a hyperplane. So instead of a line, which crosses a 2-dimensional space, we're going to have this kind of like a layer which distinguishes or is able to classify between things that are above this plane, and there are gray roots, and things that are down below this hyperplane, and these are oranges. If we could go one step further to add 4 dimensions or 5 or 10,000, these same equations work for even millions of dimensions. We cannot visualize them, but they work really, really well. So as a high-level overview of one of the algorithms that is used in machine learning, we saw linear regression, and it's just one of the algorithms that are used. There are more and many algorithms, and there are more algorithms coming out as we progress. So make sure to watch the references on the slides. These 4 are really some of the best resources I found for introducing yourself to machine learning, especially this visual intro to machine learning. Another algorithm, another system that we use to train machine learning models are neural networks, which are close to like the way our brain works. So we took the model of a biological brain and biological neurons, and we recreated some kind of an artificial neural network. And these artificial neural networks are one of the most powerful machine learning algorithms out there. So you can read more and you can learn more from these resources. And something like Skynet. So now that we saw that we got like a taste of how these algorithms work, using some numbers and using some math, let's go into image classification. So let's understand what image classification using machine learning is. So image classification is just the task of identifying what an image represents. An image classification model is trained to recognize various classes, as we say, of images. So you may train a model to recognize photos representing 3 different types of animals, 3 different classes. So we can have rabbits, hamsters, and dogs, let's say. During the training, an image classification model is fed with hundreds and hundreds of thousands and even millions of images sometimes, and their associated labels. So we have 10,000 images of rabbits with the label rabbit. We have 10,000 images of hamsters saying this is a hamster, and then 10,000 images of, let's say, dogs saying this is a dog. So we train the model, we train some kind of algorithm, and of course, its label is the name of a distinct concept or class that the model will learn to recognize. We train the model, and given sufficient training data, like enough images per label, an image classification model will be able to learn and predict new images that belong to any of the classes that this model have been trained on. So we give some new images of either a hamster, a dog, or a rabbit, and the model will be able to say, okay, I can say that I'm 80% sure that this is a rabbit, or I'm 50% sure that this is a dog, or something close to a probability. This process of prediction is called inference. This is what we get out of this model when we give it some new data. So let's see an example of a Silicon Valley style classification, just to have a bit of a laugh. I hope you can hear the sound. Let me know if you can hear the sound.
What do you say if I told you there's an app on the market? That's that part. Just demo it. Okay. Let's start with a hot dog. Oh shit! For the fuck! Huzzah! Junior, a beautiful little. block a view of light. You will have 12 hooks braided palm trees that will feel exposed again. A little bit of your rage. Oh, keep getting full. Do pizza. Let's do pizza. Yeah.
Not hot dog.
What the fuck?
That's it. It only does hot dogs.
No, and a not hot dog.
Okay, this is from the Silicon Valley series. I know the sound was, you couldn't hear the sound very well, but this was actually a really funny part where they train, this Jin Yang developer trains an algorithm to detect between hot dogs and everything else that's not a hot dog. That's just one of the funny parts of, let's say, the series. So let's do some demo right now. We're going to train an image classification model using the simplest possible method possible. So we're going to use a site called Teachable Machine. I'm going to open this and send you the link. Oops, no, sorry. Okay. Okay, a wrong link then. I have the wrong link. So this is the link. Sorry for that. Let me share the video. Yes, let me share the YouTube video. Okay, for watching later, of course. This is the okay. What is Teachable Machine? Teachable Machine is a website that's created to. Okay, let me copy. But we're able to play with some and train some machine learning models, and then we can use them on our website. So you can do all sorts. You can run all sorts of experiments in this website. We're going to use it to train an image classification algorithm and use it for our shopping, to enhance our shopping experience. So a couple of things before I'm going to demonstrate this is that Teachable Machine, this website, uses a pre-trained image classification model. So there was a bunch of images fed into a machine learning algorithm that at some point understood or was able to distinguish between different classes of images. The model that Teachable Machine is using is called MobileNet. And it also uses a concept called transfer learning to classify new images. So MobileNet can distinguish between 1,000, I think, classes of images. It can distinguish between 1,000 different objects, as you will see. But if we use the knowledge that this model has, we can make it learn new images. So think of it as a kid which knows the dad and the mom, and then we train, let's say, this kid, or we teach this kid to also distinguish between its aunt and its uncle. So we're going to use MobileNet and on top of MobileNet, we're going to use a method called transfer learning. So on top of the knowledge of MobileNet, we're going to classify some new images. We're going to learn about transfer learning and talk about the transfer learning a bit. So let's see how we can train this this model. So I'm going to hit get started, and I'm going to show you how I created the shopping example. So we go into the get started and we hit the image project. Now in here, we're going to create the classes of images that we want to distinguish between, to classify. So I have 3 products like right now in my desk. So I'm going to classify a product called green tea, a product called parboiled rice. I'm going to add another class, and this will be tomato soup. And then I'm going to add another class, which will be nada, for nothing, if there is no product in the image, let's say. So the way that Teachable Machine works is that we hit the webcam here on the green T. We see my webcam, and I'm going to hold the green T right here, and I'm going to hold the hold record button, and I'm going to get some snapshots of this green T. So I'm going to get about 100 samples, 100 of images, and then I'm going to take some snapshot of the parboiled rice. So I'm going to hit webcam, and then I'm going to hold this button. So let me. So 100, above approximately the same number of images. Then I'm going to go to tomato soup. So there's a little bit of a light here reflection, but let's hope that it will not. Okay. And then I'm going to add some images or some snapshots for me just standing here, so that it is the class of images that have no product, let's say. So I'm going just to, okay, just images of me. So we have like 4 classes of images: 100 images of green tea, 100 images of parboiled rice, 100 images approximately of tomato soup, and 100 images of just me. So now I'm going to train the model on the browser. It's going to take a little bit. So let's, so it's training. And as you can see, these are the training cycles. So for its training cycle, it goes through the images, it tries to classify them and find the perfect equation to distinguish between these images. And then it tries again and again. And after 15 epochs, as they are called, 15 cycles, it is able to distinguish between these 4 classes. So as you can see here, the probability of nada, of nothing in the screen, is almost close to 100%. So this is not accurate, it's not 100%, it's 99.99. If I hold the tomato soup, you will see it kind of goes to almost 80, 90%. Now, if I hold the green tea, it will classify the green tea. If I take the parboiled rice, it can understand. So in just a couple of seconds, we were able to train a machine learning algorithm right on the browser using JavaScript and using TensorFlow.js, which is running behind Teachable Machine. And now I'm going to close this. And now I can use this model on my website. So I'm going to go to this export model, and I'm going to go to download. And I'm going to grab this copy, I'm going to copy this code. So I'm going to copy this code. And I'm going to go into VS Code. I'm going to create a new file called classification HTML. I'm going to paste the code here. We'll go through the code in a bit. So this is just a part of the HTML. I'm going to first create a basic HTML and place the code inside the body. And let's format the document. So this is the code that I pasted. And then I'm also going to download the model. So the train model, I must go to download. So this is just the code that will enable me to run the prediction. So I downloaded the model. And I'm going to take the model. Okay, so let me transfer language. So this is my model that was downloaded from the Teachable Machine. I'm going to unzip it, and I'm going to rename the folder to my model. So this is the model, this is the trained model, this is the brain that we downloaded. These little things, these three files, are able to distinguish between parboiled rice, green tea, tomato soup, and myself. And this is around 2.2 megabytes. This meeting is recorded, yes, Curie. So we have the model and we have the code right here. So let's open this code and we'll see how this works. So I'm going to open it with a live server extension on VS Code. So be able to see it on the browser. And I will be able to press the start button, wait for the camera to be enabled, and then I can see the predictions here. So we have nada for like 1.0. Then we're going to have green tea, as you can see, close to 1, 99. We're going to have the tomato soup, and we're going to have the parboiled rice. So all the system, all the models, all the code was downloaded on my machine. And let me put this here. And walk you through the code. Just a quick overview of the code that we downloaded. So what we have here, no, we are here. So first of all, we have this button. And this button initializes the application. So this is where we execute the init function. We have a webcam container that will let the webcam image be shown when we enable the web camera. And we have the label container that will show the classification probabilities. So these are just the DOM elements. We have the URL. This is the folder on my local machine where I downloaded the model files, some variables. And when we hit start, we initialize, we execute this function. This is the main initialization function. What does this function do? First of all, we create the URL according to the folder name. So we create two paths, my model / model JSON and my model / metadata. And this will be used in order to download, to fetch, to load these files from the local folder. So I have this my model, and I need to load these two files in my application. So this is just easy. Then we use the Teachable Machine image method, which is async. So we use a wait, and we load the model. So this is where the model is loaded on our machine, on our web page, and then we will be able to train. We're not going to train. It's already pre-trained. We will be able to predict using this model. So we're going to first load this model. You will see that after, if I put a console log message here, it will, okay, it's fetching the files, as you can see, the model JSON, the weights, and then after a while, the model is loaded. And then we get here from the model, we get the total classes. Total classes meaning the 4 classes that we trained, like tomato soup, green tea, and so forth. You can find this information in the metadata JSON, in the model JSON. In the metadata. So if we take a peek at the metadata JSON that was downloaded, we can see an array of the 4 classes. So green tea, parboiled rice, tomato soup, and nada. I will copy these classes. And then we get here to the point where we enable the webcam. So this is just a helper function from the Teachable Machine code that it will load this 2000 by 2000 box. And we can see the live feed from a web camera. Okay, this is the part that actually runs, sets up, and enables the camera. And then it uses the window request animation frame, which is actually something like a loop. So it runs this function many times per second. So this function will be run again and again and again. In these next lines, it just goes through the classes, the prediction classes, so the 4 classes, and it creates 4 document elements, like 4 divs, in order to display the probabilities for its prediction. So the things that you see here, these 4 divs are created right here. So if we had 5 classes, it would have created 5 divs. If we had 3, and so forth. So for 4 classes, it creates these just divs. And then once this is finished, the init function will be run just once. It goes through this loop, and this loop runs this function, the loop function, again and again, many times per second. So what does this function do? It updates the camera so that we get a live feed every single time. If I comment this out, I will comment this line, you will see that the camera will be activated, but I will only see the first frame or nothing at all, because the loop runs all the time, but the webcam method is not run, the update, so I don't see nothing. So in order to see something here, I need to uncomment this. And for every single frame, every single time that the camera gets updated with a new frame, it also runs this predict function. And this is what actually gets the image and predicts the class of the image, whether it's green tea, parboiled rice, nada, or tomato soup. And the predict and the loop before it finishes, it runs itself, so that we have a continuous loop and we have the camera running all the time. Now the predict method actually gets an image from the webcam. So it grabs a snapshot, an image from the camera running at that point, and it goes through the predictions and it classifies them. So with the predict method, it gets an image and it gets back some results. So for each class, we get some kind of probability and some kind of and the class name, the name of the class. So to console log this, or no, we don't need to console log this. You will see this here on the divs. So we add this HTML with the class name and the probability here underneath the video, you will see. So these things are updated every single time something is shown here. So the loop runs, it predicts constantly, and we get these predictions updated here. Now, if we're going to create something like an eShop, we don't want the camera to constantly running and predicting. So we're going to comment this. We don't want to predict every single second or multiple times per second. So we need to run this predict function only when there is a button clicked. So the user will be able to scan, to point the camera towards a product, and then scan the product to see if we get a product from the scanner. So I'm going to create a button. And I'm going to say on click equals predict. and I'm going to say scan. So now only when we press this button will the function predict run, and then we're going to get the prediction here. So instead of constantly running and predicting images from the webcam every single millisecond, we're going to make it a little bit closer to our needs. So let's start the camera. You can see no predictions here because we commented the predict function here. So the predict can only be executed when we click this button. So let me scan, and we get tomato soup. You can see the probabilities get lower or even higher at some point. So we get 98%, and then green tea, and then we have parboiled rice. So now, if we want to make the shopping experience better, we're going to use the 4 classes. So I think I have them here. So I'm taking the 4 products here, and I'm going to say, or I have the products here. The product name is also taken from this, the class name. So during the predictions, I'm going to console log. So I'm going to say, going to use some variables to help me. So predicted class, or let's say just product equals this, just to make it easier for us to work with the code instead of this. And the probability of how likely this is to be a product X, let's say. I'm going to say prob. And now I'm going to console log the product and the probability just to see it on the console. So start, let's scan. Okay, so I'm going to scan. And as you can see, during this scan, we got this for loop running 4 times for green, rice, tomato soup, and nada. And we see the product. This is the product and the probability. So now I want to add the product to the cart. Once I scan the product, I want to add the product to the cart only if the probability of having detected this product is high enough. So 1, it's like 100%, it's close to what I want. So I will create a threshold. Let's make it 0.88. And I will say that while I'm predicting the products that are scanned, I will say if the probability is higher than the threshold, so if I get a good probability of having detected a specific product, I'm going to add this product to our shopping cart. So I will create an object here. This will be an object. And if the probability is higher than the threshold, it means that this product is actually the product that I want added to the cart. So I'm going to check if the cart object contains the product already. In the beginning, the product object, the cart object will not contain anything. So I need to add a property. So if there is no product in the cart, I'm going to add it. And this will be an object with total of 1. So this is the cart. When I I scan, let's say, the green tea, this will become say green tea total 1. So this will be the structure. For each product, a new property with the total number of products added. But since I start with an empty cart, I might want to either put the properties here, or I dynamically create them if they have not already been added. So I'm adding the product so that I don't have a cart with objects or products with 0 total, 0 items. So if there's no product in the object, I create it and I add this. Otherwise, if it's already there, I'm going just to update the total. And after this prediction, I'm going to console log the cart. So let's check our new shopping experience. So let's scan. Okay. So we have nada, which is something I haven't, I have to put a conditional not to add nada. Okay. So let's see if we can add a tomato soup. So we have the tomato soup and another tomato soup. So we have our cart with 2 tomato soups. Let's add a couple of rices and another green tea. And after a few scans, we have our shopping cart. So 1 green tea, nada, parboiled rice, and tomato soup. So all the products were scanned, and I have now my shopping cart, which I can update, of course, visually in my page. Of course, here I need to add another condition and say if probability is above the threshold and the product is not nada, because I don't want nothing, then this will probably just add the products and not nada. So let's see if it works. Yes, it works. I scan and I scan again, and nothing gets added when I scan because I have nada, nothing, and I only got the tomato soup. So this is just as easy as it can get to training an image classification algorithm in machine learning, downloading it and embedding it into our web page. Now, let me give you another idea of using this very simple way to train an image classification algorithm. So this is an idea for using this training algorithm to let people that are not able to move their legs or their hands control the computer. So I found this game, which is called, you all know the game. So it's this game where you can hit the left and arrow keys to be able to play this game. So I found this game and I decided to use machine learning to be able to play it with movements of my head. So what I did is I went to the Teachable Machine and I trained the algorithm to do a new project. Leave, yes. So I trained the algorithm with 3 movements: left, still, and right. And this is how I trained the algorithm. So first of all was like, let me, okay, now I have to use, okay. I will let my head move to the left. Then I will stand still. Okay, and then I will like hold this for the right position, something like this. So for example, there might be a person that's quadriplegic, someone cannot move their hands or their feet, and the only thing they can move is above the neck movements. So I train the model, I download the model, and then I integrated this model in this game. And now we have paddle ball brick game with TensorFlow. So let's see how this works. So I start the camera, which I can hide, of course. This is just for me. And when I do this, it moves to the right. Okay, this was trained with another angle, but let me see if okay, I will download the model. So this was trained with another angle and with another lighting. So let's train this model. Now it's training, it's going to take a while. We can always manipulate the parameters here to make our predictions better. I'm going to export the model. And then I'm going to go to this paddle brick game. And I'm going to go to downloads. So I'm going to unzip my model. This is my model. And then here, I'm going to change just so, and I will show you where I webcam. Okay, this is live session. And the only thing that I changed in this code, this game was not created by me. The only thing is that I found the code where it uses the keys to train, sorry, not to train, to move the ball with the keys. So moving to the left or to the right using the keys, and added and replace this code with predictions from the model. So let me, first of all, close this one and run this now. I think it will work. So I can move my head and let's try to play the game. Let's see if it's kind of tough. Okay. Okay. As you can see, we can play the game using head movements. Of course, you can apply this to any kind of ideas. So there's a question about how we can do that with every head too. Okay, so that's quite a challenge. And this means that we need to train lots and lots of pictures, lots and lots of, yes, more samples and many people. Now, since this question came up, I'm going to show you a model. You can use a TensorFlow model. So TensorFlow, another trained model, TensorFlow.js PoseNet, where you don't need to classify images, but you use the pose. You detect the pose of the body. So there's a model that you can use with TensorFlow.js, and it can detect movements and the body and the eyes. And you can use that for that. So this is another model that was trained based on the anatomy and the pose of the human body, and it can detect different poses. So So you can use this model. There are different, let's say, solutions or approaches for we have many models available for TensorFlow.js. So let me go to TensorFlow.js. We have the MobileNet, which is able to train to classify images. We have image classification models. We have object detection models, body segmentation. It can detect different parts of the body, understand the toxicity in texts, the pose, understand natural language, speech recognition, face detection, hand pose, face landmark, detect the expressions on the face, and other natural language models. So for example, using the object detection model, we can, let's see, there's a demo. Okay, it can detect like 80 classes of objects, like a person, a bicycle, a motorcycle. It can detect where the objects are in the image, in the picture. And there's also, let's see, the hand pose detection. So you can see here, it can detect whether we're waving, whether we have an open palm, and we can, of course, command the computer using hand gestures. So there are different models for different use cases. So we can like a Facebook post using just the thumbs up on our camera. So we can learn more about these models here. TF.js models. And I want to move, because we're kind of running out of time, I want to move on to the presentation, the next steps. So under the hood, Teachable Machine uses TensorFlow.js and MobileNet. So MobileNet is able to detect some objects. But on top of that, we can use transfer learning to classify new images. So MobileNet cannot classify like green tea or parboiled rice or my head movements. But if we use the knowledge of MobileNet and use transfer learning, we can classify new images that MobileNet hasn't seen before, and we'll be able to predict these new unseen image classes. MobileNet is a machine learning model for image classification and mobile vision. It's called MobileNet because it's lightweight, it's fast, it doesn't require much computation power, so we are able to use it on our mobile devices. And it supports these classes here. So these are all the things that MobileNet can detect, can classify: goldfish, hammerhead, some strange things, to be honest, a wolf spider, a centipede, and some ambulances. There are some really quite of a variety of things. As you can see here, animals, lots of animals, and then let's go CD player, a cassette player. But on top of this, we can train this model to learn more things. So that's the power of transfer learning. Make sure to see these YouTube videos and read more about how image classification works. Especially this link is really great. It's a TED presentation about machine learning and image classification. And let's talk a little bit about transfer learning. So transfer learning is the process of storing knowledge gained while solving one problem and applying it to a different but related problem. What this means is that we train MobileNet, we train a model that's called MobileNet to distinguish between 1,000 classes of images, 1,000 different things depicted in the images. We store this knowledge, we store this model as a file, let's say, and then on top of that, we use this knowledge to learn something new, to learn new objects, to learn new things in images, just as we did with the 3 products. So this is really powerful because you don't have to start from scratch. You don't have to train a model to understand images and go through the process of understanding the details and stuff like that. You get something that was already trained, and on top of that, you build another model that will gain new knowledge. This is somewhat like using the skills you learned in your previous job at your new exciting workspace. For example, knowledge gained while learning to recognize cars could apply when trying to recognize trucks. Now, this is not related to the job, but another example is to think of transfer learning as you first teach someone to recognize cars, and then while that person is able to understand cars, it will be easy to train him and teach him to recognize trucks, let's say. You can think of a kid. So in order to see more and learn more about transfer learning, there is this great code lab by Google, and which are the makers of TensorFlow. So if you go to this TensorFlow transfer learning image classifier, I will walk you through what this code lab is. It's pretty easy. It takes you step by step. So this introduces you to image classification. So you follow the steps, and you actually, you read, of course, the instructions, and then you copy the code. So in the beginning, it teaches you how to run TensorFlow.js and MobileNet on your browser without ever going to Teachable Machine. So this is just bare bones TensorFlow JavaScript code running an image classification using MobileNet. So you take this file, you copy it on a new web page, and then you set up MobileNet using this code, and it will be able to predict some images. So when you finish these 3 steps, just by copying and pasting the code, and of course studying the code, you will see something like this. So steps 3 to 5, there will be just these lines of code. And what will this do is it will load this page, and there will be an image here, which is hard-coded. This is the image. And it will run the MobileNet based on TensorFlow.js, and it will predict the image. So after the image is loaded and the model is loaded, you will see an array of the probabilities of the 3 most prominent, let's say, classifications. So as you can see, the Kelpie, I don't know, this kind of dog, is high of probability. Well, not exactly high, but about 52% of being this dog depicted here. If we change the image with something else, so if I go to, this is transfer 345, I'm going to use the image of a hot dog. So I'm going to replace the image of the dog here with, I'm going to go to image and hot dog. It will load MobileNet and will do a prediction on this image. So let's see the prediction. So we have a hot dog prediction of high probability, 93%, as you can see, lipstick for 0.009, as you can see, and band-aid. Okay. Now I will also try some other classes that MobileNet can detect. So I will try, I have, I think, an ambulance, some ambulance, yep. I'm changing the image to an ambulance. And after a while, let's see, it will say this is an ambulance with probability not exactly high, like 51%, a moving van, close, a trailer truck, a tractor trailer, or this. These are 3 of the 1,000 classes that MobileNet can detect, can classify. We still haven't done the transfer learning that we did before with Teachable Machine to train the MobileNet or more images. So up to step 5 in here, you will just have MobileNet set up on a web page and be able to load an image or drag and drop an image or let the user open an image, and the MobileNet model will be able to give a prediction of what we're seeing in this picture. The next steps here walk you through the steps of running MobileNet inference in browser through webcam. So if you add these lines on the web page that we created and you update the app, you will go to step number 6. So the code will be updated. And this will give you this will give you this thing, the camera, and then it will give you a probability of what it sees. As you can see, there are all sorts of crazy things, but if I try to use a coffee mug, you can see that it kind of predicts, okay, bucket, it's trying to decide between a coffee mug and a bucket with very, very low probabilities. Let's see what it does with this one. Okay, it hasn't seen a tomato soup, so a hairspray, I guess. And I don't have any other element that's like being classified by MobileNet. So on this next step in this code lab, you will get up to this point. So just use your web camera to detect one of the 1,000 MobileNet images. And the next step, it's to build exactly what we did using Teachable Machine, but without going through the site. So if you follow step number 7 and update it with a script, some HTML, and some updated code here, you will find yourself on step 7. I'm going to run this here. I still have the image of the dog with it's not needed. And you're going to have like these 3 buttons. And this works exactly as the Teachable Machine, but just using this TensorFlow.js library without any external help from Teachable Machine. And we can press this button, and we're able to classify things like tomato soup. So this will be just class A, B, and C. I can change this to tomato soup or something like that. So I will train it with images of the tomato soup. And every time I click, it will be trained on this image. I will also train it for me, like no product at all. So I'm hitting the add B and I'm training it for the class B with just me. And then I'm going to use the parabolic rise for C. So right now you see B, this is me, this is C, and this is A. So we were able to do what we did through the really nice interface of Teachable Machine and the very helpful code, but without any external libraries or just some JavaScript code and TensorFlow.js. So if you want to create something to be able to classify some images in different ways and you don't want to like go into Teachable Machine, you can do this with this code. And I think this is a really nice code lab. This is a really nice walkthrough to play around and learn about how to use image learning on a web page and also do some transfer learning. This is a great tutorial. we don't have enough time to like go through the process, but it's just some copying and pasting code from the code lab, running it on our local machine, and also, of course, studying the code, because you have to go into this code and understand what each example does. And then you are able to tweak the code and do whatever you like with this. So from Teachable Machine, which is, let's say, the easiest way to introduce yourself into image learning, we can follow this code lab and play around with image classification in a little bit more advanced and more plain JavaScript, let's say, way. And if we want to go one step further, if we have thousands of images, and if we want speed and accuracy, and we want enterprise, let's say, grading machine learning level quality, we might want to use Google AutoML Vision, which is a web service by Google that enables us to upload thousands of images, and through a very useful, very user-friendly interface, we are able to train images and manipulate and tweak the parameters to get back a model to either use through an API or use it, download it and use it through TensorFlow.js on our browser. So if we want to do some really heavy training with thousands of images, we might want to use the AutoML service by Google because our browser will not be able to handle this. But when we train the model, we're able to download the model and use it with TensorFlow.js as a pre-trained model. Why should we use AutoML, or when? So first of all, it enables developers with limited machine learning expertise to train high quality models. So this requires no code. You just upload the images, set up the classes, and tweak some parameters, and then you get a pre-trained model that you can use in many ways. You can export the model by AutoML and use them with TensorFlow.js, just like we did with Teachable Machine. You have large dataset support. So instead of using MobileNet, which is trained on, I don't know, a couple of million images and understands or classifies 1,000 classes, you can use some really, really good image classification algorithms that are able to classify thousands and thousands of different objects or images, so more powerful sets. It's very easy to deploy and to scale the models. And you can use the models as REST APIs. So you can even just do AJAX requests to the services, upload some images or send some data, and get the results back as a JSON file, let's say. You can find more about AutoML in these tutorials and these links here. A couple of resources that you might want to check out. You can find some demos with TensorFlow.js here. You can connect with the TensorFlow world community. You might also want to check out this Made with TF.js Twitter hashtag to see all the cool things that come up daily with TensorFlow.js. So this is a Chrome extension that triggers dark mode by clapping your hands. So let's see what, okay, let's see if we, I don't know if you can see it, but she claps her hand and the browser theme turns into dark mode, which is actually pretty funny. And in this thread, you can find some really, really cool examples and things created with TensorFlow.js. So make sure to check out this this thread. And as you can see, there's another example, a demo of controlling a keyboard using the eyes. So once again, with TensorFlow.js, this model has been trained to detect the eye movement, and it is able now to select the keys from the keyboard, let's say. So you will find some really, really cool demos here. And also there's a really nice Coursera course for building browser-based models with TensorFlow.js. So if you want to dive even deeper, this is a really nice course. So that's it from me. You can find me and connect with me on this through these channels. We have a couple of minutes for some questions. So let me stop sharing and let's see if we can have, do you have any questions? I hope you enjoyed and this talk inspires you to learn more about TensorFlow.js. I can share the link for the Coursera course, yes, of course. I will put it on the notes and I will send it to you right away. Thank you for attending. We will posting the recording. Thanks everyone, and hope to see you on one of the upcoming webinars. Yes, let me give you the link to the notes, sure. I will share, yes. Let me share the YouTube channel by the school that I'm currently teaching. So let me give you let me send you just I will be pasting here. So this is the Social Hackers Academy YouTube channel and my personal channel. I don't have much at this point, so I post them through other channels. So, but thanks everyone. I'm just going to so this is my personal YouTube, so I don't post often there, but you can find some JavaScript related videos. Okay, hope you enjoyed and see you. Have a good evening. Bye bye everyone.